So far we have seen what waves are and how they are formed. Now let us see how they superpose on each other. The theory that we will see is general, so it is applicable to all sorts of waves. So we can start with some simple example like say ripples on water. For that we can take a tank like this and fill it up with water. Then in it we can introduce two sources of disturbance, so they will produce ripples like this. Ripples are nothing but expanding circles of alternating crests and troughs like this. The second source will do the same thing and the two patterns will overlap. Now wherever two crests of the waves come together, both will try to push the water surface up, and therefore their displacements will get added to give even a bigger crest. For the same reason, two troughs will come together at certain points and form a deeper trough. These points are called points of constructive interference because the two waves or the displacement of the two waves is getting added. As opposed to that, we may have a trough of one wave and the crest of the other coming together, thereby trying to cancel each other, and this is called as the destructive interference. We can connect all the points of constructive interference to see the pattern that they will form. And similarly, destructive interferences will also form a pattern. To see them clearly, we will turn off the ripples and the water. So this is how the pattern is formed. Now, if the two sources that we have taken have the same frequency, and if the phase difference between these two sources remain constant, in that case, the pattern remains steady with time. It doesn't change. And in that case, we can predict the state of interference at any given point in the tank. To find the state of interference at a point, say like this A, B, C, D here, we need to know how the waves meet at that point. If they are in step or in phase, the crest will meet a crest causing a constructive interference. And if they meet out of phase or out of step, then it will form a destructive interference. This can be easily observed from the cross section of the ripples like this. So here we can see at point C, a crest is meeting a trough, thus there will be a destructive interference. We can move this intersection of the waves to some other point, say A, and see that there is a constructive interference. So like that we can check it at various points. Say at B, we are having a constructive interference again. But what does it depend upon? What really decides with the state of interference? It is the distance of that point from the two sources, because the distance decides the phase in which the wave reaches that point. This phase can be found by counting the number of half waves accommodated between the source and the point. For example, here we have 1, 2, 3, 4, 5, 6 half waves within source 1 and point C, and 1, 2, 3, 4, 5 half waves between source 2 and C. So the two waves will reach here, there will be a difference of half a wave or 180 degrees, which makes them out of phase and therefore they interfere destructively. At some other point, say like this point A here, let's do the same. So here we have 1, 2, 3, 4, 5, 6 and 7 half waves from source 1 and 1, 2, 3, 4, 5 half waves from source 2. So that gives us a difference, a path difference of 2 half waves or one complete wave, which is 360 degrees, and therefore both the waves will arrive in phase and interfere constructively. In fact, we don't even need these pictures of waves. All we need to do is just measure the distance of the point from source 1 and source 2, say D1 and D2, and take the difference of these two distances. Within this difference, we need to find how many half waves can be accommodated. So let's divide that path difference by lambda by 2. If this ratio turns out to be an even number, it will give us a constructive interference, and if it is an odd number, it will give us a destructive interference.